Before we begin, find yourself somewhere comfortable and let your shoulders soften a little. This is a story told at the pace of starlight, meant for those quiet hours when the mind is ready to wander and wonder. If sleep arrives in the middle of a sentence, that's perfectly fine. The mountain can wait, and the ocean will still be there when you return. 300 miles off the coast of Oregon, far beyond the everyday edges of roads and streetlights, something ancient is doing what it has always done. A mile beneath the surface of the Pacific, in water so dark that sunlight never reaches the seafloor, the Earth is quietly moving in a way we can measure, and yet never really tame. Not with drama, not with a warning siren, but with a steady, almost patient swelling, as if the planet itself were taking a slow breath in. It helps to imagine the ocean above it first, because the ocean has its own kind of hush. It presses down in silence, layer after layer, cold and heavy and constant, until the world becomes a place of pressure and shadow. Down there, the landscape isn't soft. It's stone that once flowed like liquid, frozen into ripples and folds, as if time itself hardened mid-motion. And in that darkness, in a place no human body could ever simply wander into, a mountain sits with the unhurried confidence of geology. The mountain has a name, Axial Seamount. It's not the sort of volcano most people picture, not a cone you can photograph from a roadside viewpoint, not a snowy peak in the distance, not a jagged silhouette against a sunset. It's a shield volcano built by repeated lava flows over long stretches of time, broad and rounded, more like a vast dome than a spike. Its summit rises up through thousands of feet of seawater, still deep enough that a ship could glide over it without noticing, still hidden enough that it can spend its whole life doing extraordinary things in total privacy. And yet, even hidden, it leaves clues for those who know how to listen. Instruments can feel what human senses cannot, the way the seafloor lifts by centimetres over months, the way tiny earthquakes flicker through the crust like soft taps from inside a locked door. Scientists sometimes describe Axial as inflating, as magma slowly refills a chamber beneath it, pushing the ground upward in a gradual swell. It's a strange word to pair with something made of basalt and heat, but it's also oddly gentle, like the world is taking a deeper breath than usual and holding it for a while. If the mind wants a simple picture, it can think of a long, slow tide. Except the tide is not water this time, it's rock made temporarily fluid by heat, gathering where it can, finding space, nudging at the boundaries of what will hold. The surface world goes on as it always does. People make dinner, reply to messages, plan tomorrow. Somewhere, rain moves through cedar branches, rivers carry salmon, cities glow and dim and glow again. And all the while, beneath that familiar life, the planet continues its older life. The one made of plates and pressure, of slow collisions and deep rearrangements. Because Axial does not exist alone. It sits in a place where the Earth is especially busy, even if it looks calm from above. Off the Pacific Northwest, the Juan de Fuca plate slides beneath the North American continent, at a pace that sounds almost laughably small, about the width of a thumb each year. But the Earth is patient with small numbers, and it turns them into mountains, into earthquakes, into centuries of stored tension. And out there on the seafloor, Axial perches on the Juan de Fuca Ridge, a spreading centre where new oceanic crust is created as plates pull apart. As if that weren't enough, it also sits above a hotspot, a plume of heat rising from deeper within the planet, feeding the system with a steadiness that makes Axial unusually active. Active here doesn't have to mean frantic, it can mean regular, almost rhythmic, like a slow heartbeat you only notice when the room finally gets quiet. Axial has erupted in 1998, again in 2011, and again in 2015. Each time there's been a familiar pattern. Years of swelling, a growing chatter of small earthquakes, and then the release. Lava flowing across the seafloor, and the summit area dropping as the magma chamber empties. During the 2015 eruption, the caldera floor dropped by more than 2 meters in a matter of hours, a reminder that even the most gradual breath can end in a sudden exhale. The word caldera sounds dramatic, but it's simply a shape, a bowl-like depression formed when the ground collapses after magma drains away. At Axial, the caldera is not a perfect circle, but an unusual stretched rectangle, roughly 3 by 8 kilometers, hinting at forces and fractures that don't fit neatly into the shapes we prefer. Inside it, the seafloor is a record of past motion. Ropey textures where lava cooled smoothly, jagged blocks where it broke and piled, and vents where hot, mineral-rich water rises into the cold ocean like a ghostly kind of weather. In some places, black smokers build chimneys of minerals, and life gathers around them. Tube worms, crabs, microbes, proof that even in darkness, even beside heat that can destroy, nature finds a way to persist. It's easy, when hearing about volcanoes, to feel the old instinct to tense up, as if the story demands alarm, but it's okay to let that go here. This mountain is far offshore and deep underwater, and its eruptions are typically more like flowing fire than exploding sky. The point of watching Axial isn't to frighten anyone awake, it's to understand something that is usually hidden, and to practice listening to the planet in a way that might matter elsewhere someday, when the stakes are closer to home, and even that thought can be held gently, like a stone warmed in the hand. Serious, yes, but steady, and strangely comforting in its honesty. There is a particular calm that comes from admitting that the Earth is not arranged around human schedules. Volcanoes do not keep appointments, they do not respond to calendars, or to the nervous hope that things will stay the same. They simply follow physics and pressure and the slow supply of heat from below. Scientists have forecast that Axial's next eruption is likely in 2026, but the timing has shifted as the mountain's behaviour changes, as inflation speeds up and slows down, as earthquake patterns rise and quiet again. Uncertainty in this case is not a flaw in the story. It is the story. It is what happens when people try to understand a living planet without pretending they can command it. So the image to carry forward is not a ticking bomb, not a dramatic countdown, but a breathing mountain beneath the waves, a slow swell, a patient gathering, darkness above it like a blanket, and water pressing down like a hand that never lifts. The surface world sleeping, waking, working, laughing, worrying. While far below, the planet rearranges itself in the only way it knows how over and over again for hundreds of thousands of years. And if, as you listen, your thoughts begin to drift, if the details blur into the broader feeling of water and stone and time, that's all right. That drifting is part of the design. The deep ocean doesn't rush, and neither do we. In the next chapter, the story will move closer to the listening itself, to the cables and sensors resting on the seafloor, to the quiet stream of data travelling back to shore, and to the strange, beautiful idea that humans can sit safely on land and still keep company with a volcano in the dark. There are places on Earth where human curiosity has built something quietly remarkable. Not monuments meant to be seen, but instruments meant to listen. The seafloor off Oregon is one of those places, and understanding what lies there requires imagining a different kind of connection. Not a journey, but a tether. Not a visit, but a conversation that never ends. For most of history, studying a submarine volcano meant launching expeditions from ships, sending down submersibles for brief visits measured in hours, gathering snapshots separated by months or years. It was like trying to understand a forest by looking at a handful of photographs taken in different seasons. Useful perhaps, but missing the continuity, the rhythm, the small changes that only reveal themselves through patient watching. The ocean kept its secrets simply by being dark and deep and vast, and scientists worked with what little they could gather before the ship had to turn back toward shore. But something shifted in 2014 when Axial Seamount became part of a network called the Ocean Observatories Initiative, an ambitious system that runs fibre optic cables across hundreds of miles of seafloor, connecting instruments to a continuous power supply and streaming data back to scientists on land in real time. The concept sounds almost impossible when said plainly. Run a cable nearly 900 kilometers from shore, establish monitoring stations in water so deep that pressure would crush anything not specifically built to endure it, and keep the whole system running for years without constant human intervention. And yet, that is exactly what was built. The cable itself carries both power and data, threading through underwater canyons and across ridges, branching at various points to supply nodes that distribute electricity and connectivity to individual sensors resting on the volcanic summit. Seismometers listen for earthquakes, recording tremors so faint that no human standing on solid ground would ever feel them. bottom pressure recorders measure changes in the height of the seafloor with a precision that borders on the surreal. Millimetre by millimetre, they track how the mountain swells as magma accumulates below. Temperature sensors keep vigil near hydrothermal vents, noting the heat that rises from deep fractures where seawater meets volcanic rock. Cameras capture images of a landscape that looks like another planet, ropey lava textures frozen in time, chimneys of minerals growing upward into the cold, and the occasional pale crab moving through the frame like a reminder that life adapts to almost anything. All of this information travels up through the cable and arrives at a shore station in Pacific City, Oregon, where scientists can watch the mountain breathe from the comfort of an office, sipping coffee while monitoring a volcano 300 miles away and a mile underwater. It is a strange intimacy, this ability to observe something so remote and so hidden, and it has changed what is possible in volcano science. For the first time, researchers can see patterns unfold in real time rather than reconstructing them later from fragments. They can watch inflation accumulate day by day, track how earthquakes cluster and migrate, notice when something subtle shifts in the system long before it becomes dramatic. The 2015 eruption demonstrated the value of this continuous presence. In the months leading up to the event, the seafloor at Axial was inflating steadily, rising as magma refilled the shallow chamber beneath the caldera. Earthquake activity increased as rock fractured under growing stress. Scientists recognized the pattern from earlier eruptions in 1998 and 2011, and they made a forecast, a prediction that Axial would erupt by the end of 2015. It was not certainty, but it was informed probability based on observable precursors, and when the eruption began on April 24th, the instruments captured everything. Within hours, thousands of earthquakes rippled through the crust as lava broke through fissures along the caldera floor and rift zones. The pressure sensors documented the exact moment when the summit began to collapse, dropping more than 2 meters as the magma chamber drained. Temperature probes detected the thermal pulse from fresh basalt meeting cold seawater. It was the most detailed observation of a submarine volcanic eruption ever recorded, a moment when technology and geology aligned perfectly, and scientists could finally see what had always been hidden in the deep. What they learned was both reassuring and humbling. The eruption followed a repeatable pattern, which suggested that future eruptions might also be forecastable if the same precursors appeared. But the pattern was not rigid. Small variations hinted that the volcano retained some freedom, some unpredictability that no model could fully capture. The relationship between inflation and eruption seemed consistent, but the threshold varied slightly each time, and no one could say with absolute confidence where the next threshold would land. Since 2015, Axial has been inflating again, slowly rebuilding toward another eruption, and the instruments have been watching the entire process unfold in slow motion. The data arrives continuously, a steady stream of numbers describing millimetre-scale movements and micro-earthquakes, each one a small piece of a much larger story. Scientists analyse the trends, compare them to past cycles, and adjust their forecasts as new information accumulates. The current estimate places the next eruption sometime in 2026, though the exact timing remains uncertain because the volcano has its own rhythms that do not always conform to human expectations. There is something almost meditative about this process, this patient observation of forces that move on geological timescales. The scientists are not rushing the mountain or demanding answers on a particular schedule. They are simply keeping company with it, noting what changes and what stays the same, learning by watching rather than by intervening. It is a kind of science that requires humility and a willingness to accept that some things cannot be hurried, only understood more slowly over time. And there is fragility here too, a reminder that even the most sophisticated systems depend on choices made far from the seafloor. The Ocean Observatory's initiative faces uncertain funding, with proposals suggesting cuts that could silence the instruments just as the volcano approaches its next eruption. If that happens, the cabled array at Axial might go dark, and years of continuous observation would end at precisely the moment when they matter most. The volcano would erupt whether anyone was watching or not, indifferent to budget debates and political priorities, and the opportunity to learn from it would simply vanish into the same darkness that has always surrounded it. For now, though, the instruments remain active, the data keeps streaming, and scientists continue their quiet work of listening to a mountain that most people will never see. It is a laboratory beneath the waves, patient and remote, teaching lessons that might someday help protect lives in places where volcanoes do threaten cities and populations. Every observation adds to the understanding, every eruption refines the models, and every year of continuous monitoring brings science closer to a future where forecasting is reliable enough to trust. The breathing mountain waits in the dark, and the instruments wait with it, recording each small shift, each faint tremor, each millimeter of rise. And somewhere above, the surface world continues its own rhythms, mostly unaware of what unfolds below, but connected nonetheless by cables and curiosity, and the quiet hope that understanding might make us all a little safer. In the next chapter, the story will turn toward prediction itself, the challenge of knowing when a volcano will erupt, the difficulty of reading signs that are never quite as clear as we wish, and the honest uncertainty that comes with trying to forecast the behavior of something as complex and hidden as the Earth's deep machinery. In the deep ocean, where the water is heavy and the darkness feels almost kind, prediction becomes a quiet art. It isn't the loud kind of guessing that demands certainty and a date circled in red. It's more like listening for the softest creaks in an old wooden house, not because the house is about to fall, but because you're learning the language of weight and strain and time. Above axial seamount, the sea looks the same from day to day, a broad surface that doesn't show its thoughts, and yet beneath that surface the mountain continues its slow, private work, swelling in ways that can be measured, then settling into pauses that can't always be explained in a single neat sentence. The instruments from the last chapter keep their steady vigil, and what they deliver is not a prophecy, but a stream of small truths, tiny changes that add up patiently, the way nights add up into a season. This is where the human mind sometimes gets restless because the mind loves a clean answer. It wants to know, with the comfort of a final period, whether something will happen tomorrow, or next week, or not at all. It wants nature to behave like a timetable. But volcanoes do not move through the world like trains. They move like weather inside stone, complex and layered, shaped by pressures we can sense only indirectly. To predict an eruption, what scientists are really trying to do is understand a hidden system from the outside, the way you might try to picture the shape of a room by listening at a closed door. You can hear footsteps. You can notice a change in tone when someone moves from carpet to tile. You can tell when a window opens and air shifts, yet you still can't see the furniture, the corners, the exact layout. The magma beneath a volcano is like that room. It has pathways and chambers and weak points, and much of it is concealed under kilometers of rock and water, beyond any direct human glance. So the work becomes a conversation between what can be measured and what must be inferred. A subtle rise of the seafloor might suggest new magma entering a chamber, but it doesn't tell you the whole story of how that magma is behaving, how sticky it is, how much gas it carries, how it presses against the surrounding rock. A cluster of small earthquakes might mean the crust is cracking open new space, but it might also mean the system is simply rearranging stress without yet offering a pathway to release. Each signal is a hint, never a full confession. And yet hints are not nothing. Over time, patterns emerge the way constellations emerge. At first just scattered points, then a shape you begin to recognize. At axial, the mountain has shown a rhythm before. Long periods of swelling, a rising murmur of tiny quakes, and then, at some point, the moment when pressure finds a way out. Even if no one can predict the exact second, even if the details of the next release won't match the last one perfectly, that repeating rhythm matters. It suggests that the volcano is not pure chaos. It suggests there are thresholds, conditions, combinations of pressure and fracture that tend to arrive together. But patterns can lull the mind into overconfidence, and this is where the story stays gentle, because gentleness leaves room for honesty. A pattern is a guide, not a guarantee. The Earth can repeat itself for decades and still surprise you on the next turn, not out of malice, not to mock human understanding, but simply because the system is large enough to contain many possibilities. The rock is never identical from one cycle to the next. The stress shifts, pathways clog and reopen. The supply from deep below changes its pace. The volcano does not read the last report written about it. It only follows the conditions that exist inside it, right now. That is why prediction in volcano science often takes the form of windows rather than deadlines. It's a way of saying, gently, that the mountain is moving towards something, but it is still moving in its own language. It's also a way of protecting the people who have to make decisions, because certainty is a heavy thing to carry when you can't truly own it. A forecast that is too sharp can become brittle. If it fails, trust can crack. And trust, once cracked, is hard to rebuild, especially in the moments when it matters most. There's a quiet courage in admitting uncertainty, and there is also a kind of peace in it, if the mind is willing to accept that not knowing is part of being alive on a living planet. Think about how often, in ordinary life, the future arrives with the same mixture of predictability and surprise. You can feel a storm coming by the smell of air and the drop in light, yet you can't say exactly when the first raindrop will touch the ground. You can sense a change in a relationship, in a season, in your own body's need for rest, yet the exact moment when one chapter becomes another is always slightly blurred. Science doesn't erase that blur, it simply learns to describe it with care. It offers probabilities, ranges, conditions. If this continues, then that becomes more likely. If these signals align, then the risk increases. If the system quiets, then the timeline may stretch. This way of speaking can sound unsatisfying to a mind that craves a single answer, but it is often the most truthful way to speak about complex systems, and there is something soothing about truth, even when it is incomplete, because it does not ask you to pretend. At Axial, the calm part of the story is that the mountain is distant, held down by a mile of water, watched by instruments rather than crowds. That distance allows prediction to be practiced the way musicians practice in an empty room, repeating, refining, learning the feel of the notes without the pressure of an audience. Forecasts can be tested against reality. Assumptions can be corrected. Theories can be humbled in a way that ultimately strengthens them. And while all of that unfolds, the motifs remain the same. Water above, stone below, darkness around it all, and patience running through the entire system like a slow current. If the listener drifts here, that's okay. This chapter is meant to feel like sitting beside a window at night, watching nothing in particular, and still sensing that the world is moving. Because what prediction ultimately does is prepare the mind to look more clearly at consequence, without flinching. It teaches us that the Earth has many ways to release its pressure, and that not every release looks the same. Some eruptions stay quiet and contained, others become stories that reshape landscapes, skies, and lives. To understand that difference, to hold it gently without fear, is where the next chapter will go, turning from the art of forecasting to the anatomy of what can happen when a volcano's release is not far offshore in darkness, but closer to the places where people live and remember and rebuild. Source anchor. The overall chapter framework follows the user-provided transcript's arc from monitoring to forecasting. When people hear the word volcano, the mind often reaches for a single picture: a mountain with a bright wound at its summit, smoke and ash rising into the sky, urgency in every headline. But the Earth is more varied than the pictures we keep, and the ways it releases pressure are as different as the places it chooses to do it. Out at Axial, the release is usually quiet in human terms, softened by distance, held down by a mile of ocean, more like a slow spill of fire along the seafloor than an explosion flung into the air. It's worth holding that contrast gently, because it helps the nervous part of the mind unclench. Not every eruption is the same kind of event, and the difference often begins with the magma itself, with how easily it flows, how much gas it carries, and how quickly that gas can escape. Some magma is runny, able to let its gases seep out as it rises, and when it reaches the surface it tends to pour, building broad landscapes in patient layers. Other magma is thicker, better at trapping gas, and when pressure finally finds a way to break free, the release can become violent, not because the volcano is angry, but because the physics of trapped gas is simply that powerful. And then there is the setting, the quiet stage where the event takes place. Axial lives in darkness and water, so even when lava spreads across the caldera floor and along the rift zones, it does so out of sight, with the ocean swallowing sound and light, cooling the edges of molten rock into new black stone. On land, the same meeting between heat and surface can unfold in ways that touch everything: air, water, soil, and the fragile human habit of building permanent lives on a planet that has never been permanent. If sleep is tugging at you here, it's okay to let it. These are not details that need to be gripped tightly, only understood softly, the way one understands the weight of weather without trying to hold the sky. The hazards that come with eruptions are not one thing, but a family of possibilities, and each one has its own pace. Some are fast, surges of hot gas and ash that can move with terrifying speed when conditions create them, or rivers of mud formed when volcanic material mixes with water, and gravity does what gravity always does. Some are slow, ash settling across a wide region, changing the taste of air, dimming sunlight, drifting into machinery and lungs, reminding everyone that the atmosphere is not a sealed room but a shared space. Some hazards are heavy rather than swift, like the patient accumulation of lahar deposits in valleys, or the long-term reshaping of landscapes as new rock cools and fractures and becomes eventually the ground someone else will walk on without knowing its history. Yet this chapter isn't meant to pull you into alarm, because alarm is a noisy emotion, and noise is not the point. The point is to see the range of what Earth can do without treating every possibility as an immediate threat, to hold knowledge the way you might hold a lantern, steady, low, and warm, just enough to soften the dark. It's also to notice how often disasters are not only about the event itself, but about where it intersects with human life, with roads and homes and power lines, with how prepared a community is, and how clearly it can hear warnings without being overwhelmed by them. In the Pacific Northwest, that intersection carries its own quiet gravity, because the same broad tectonic system that feeds seafloor volcanism also stores stress along the Cascadia subduction zone. Off that coast, the Juan de Fuca plate slides beneath North America year after year, a slow-motion collision that feels calm until it doesn't, because stress can accumulate silently for a long time and then release in a single day. Scientists estimate there is a 37% chance of a magnitude 8 or greater earthquake on Cascadia within the next 50 years, and a 10 to 15% chance of a magnitude 9 event that would rupture the entire fault from Northern California to British Columbia. Axial will not cause that earthquake, but it belongs to the same larger architecture of motion, and watching it is one way of remembering that the ground beneath the region is not a fixed thing, only a temporary arrangement. If that sounds heavy, let it settle into perspective rather than fear. The most useful feeling here is not dread, but steadiness, the sense that understanding a risk is different from being consumed by it, and that calm preparation is not the same as panic. The Earth has always moved like this, long before there were cities on the coast, and it will continue long after, and the value of science is that it turns the unknown into something a little more familiar, something that can be spoken about in a normal voice late at night without raising the heart rate. In that way, the instruments on the seafloor, the careful forecasts, the honest admission of uncertainty, all become part of a quieter kind of safety, an attempt to meet the planet as it is, not as we wish it would be. And still, even with all that, there is a deeper lesson tucked beneath the practical ones. Volcanoes and earthquakes remind us that the world is built from forces we cannot bargain with, only learn from, and there can be a strange comfort in that, because it means the planet is not personal, not punitive, not aimed at anyone in particular. It is simply alive in its own slow way, rearranging heat and stone, making and breaking land, letting water and fire meet again and again, in cycles so long they can feel like a kind of sleep. In the next chapter, the lens will widen even further, beyond any single coastline or fault line, into the deeper history of eruptions that have changed the human story itself. The tone will stay gentle, but the time scale will stretch, the way a night sky stretches when you stop looking for one bright star and start noticing the whole, patient darkness behind it. If the last chapter widened the lens until coastlines felt small, this chapter lets the lens widen again, until even a lifetime begins to feel like a single breath taken in the dark, and it becomes easier to understand why the Earth can hold so much power so quietly, for so long, without any need to announce itself. It is okay to let the mind loosen its grip here, because deep time is not something we solve, it is something we rest inside, the way you rest inside night air when the day is finally done. Volcanoes like Axial teach patience up close, with their slow inflation and their careful, measurable swelling. But there are other volcanic stories that unfold on a scale that almost defies imagination. Stories in which the release is not only a reshaping of stone, but a reshaping of the sky itself, as ash and gases rise high enough to mingle with the larger breathing of the atmosphere. When that happens, the planet's changes can drift far beyond the crater, spreading outward the way a faint scent spreads through a house at night, subtle at first, then everywhere, touching harvests, weather, and the ordinary rhythms people depend on without ever thinking about them. This is not said to frighten you, because fear is too sharp for a story meant to be carried into sleep, but to offer a gentler kind of respect, an understanding that the Earth's most powerful moments are not always loud in the way we expect, and that some of the greatest consequences arrive softly, as dimmer summers, stranger seasons, and skies that look a little different for a while. And if your thoughts begin to drift as you picture that, if the idea of ash in the upper air turns into the simpler image of a veil drawn across sunlight, that drifting is welcome, because the truth can be held as an image long before it is held as a fact. There have been eruptions in the human past so immense that they left traces not only in stories and soil, but in the chemical memory of ice and sediment, reminders that the climate we experience is not a fixed promise, but a living balance, influenced by oceans, winds, sunlight, and the occasional sudden gift of particles and aerosols from the deep. Long after the lava cools into black stone, long after the noise fades into history, the atmosphere can carry the echo for a season or more, turning the planet's familiar pattern slightly unfamiliar, as if the Earth has exhaled and the air itself is still settling. It can feel strange to think of a volcano reaching into the sky like that, but it is simply another way of seeing connection. Water and stone, darkness and heat, and above them all the thin shared blanket of air that every person breathes, whether they live near a mountain or on a flat plain, whether they ever think about geology or not. In that sense, the biggest eruptions are not just local events. They are conversations between the deep earth and the surface world, between the slow churn below and the delicate systems above, and human life. Small, resilient, clever human life sits inside that conversation like a candle in a vast room. And yet, even here, the story does not need to be dramatic, because drama suggests a peak and a resolution, while the planet prefers cycles, and cycles are calmer. Pressure builds, pressure releases, and then the quiet work begins again, with water cooling new rock, with ash settling into soil, with forests returning where forests can, with people adapting as they always have. If there is any comfort to take from the immensity, it is that the Earth has never been a stage built only for us, and because of that, it is also never personal. It does not punish, it does not target, it simply moves through its own long patterns, and those patterns can be learned, at least in part, through patient watching. This is why the distant breathing mountain beneath the Pacific matters, even when its own eruptions are not the kind that darken continents, because it offers a quieter classroom, a place where scientists can listen without sirens, refine their understanding without evacuations, and practice the difficult art of forecasting in a setting that allows mistakes to become lessons rather than tragedies. Axial is not the whole story of volcanic danger, but it is a window into the story, a way of watching magma move and pressure accumulate in near real time, a way of learning how thresholds behave, how signals appear and fade, and how the Earth gives hints without ever handing over complete certainty. So, as this chapter comes to rest, the mind can return to the motifs that have carried the entire journey: water above, stone below, darkness that does not threaten but simply holds, and patience running through everything like a slow current that never stops. Somewhere out there, a mile beneath the waves, the instruments continue their vigil. The seafloor continues its gentle rise, and whether the next release comes sooner or later, the larger truth remains the same. The planet is alive in its own way, and it will keep breathing, whether we are paying attention or drifting softly into sleep.